SecureWorks. So normally I'm talking to people who might want to buy our services. So I'm saying, how should you defend your company and all the rest of that kind of stuff. And this morning I suddenly thought, no, the audience is different today. So I've kind of thrashed together a very different deck. You can all vote and tell me later if it's rubbish or not, but I'm going to give it my best shot, okay? So SecureWorks, we're a security company. We do 1,400 incident response engagements a year. We have 4,500 networks that we protect on a 24/7 basis. Every year, or last year, my team captured 90 million observations from our botnet emulation frameworks, which I'll cover in a minute. 3 trillion security events a week or a day. I need to double check that one. And we have 9 petabytes of data in the Wayback Engine that we could search when we find new bad stuff. I'm old. I've been doing this stuff for a very long time. My first cybersecurity incident was at Heriot Watt back in 1991. I'm the global intel lead for SecureWorks, and I'm also the chair of the Strategic Cyber Industry Group at the National Crime Agency. All mistakes in this deck are mine. All the good stuff is this awesome team that I have working for me. Lots of really experienced people who've worked in really interesting places. There's an old film called Local Hero, and in it, Fulton Mackay is asked, what's the most interesting thing that's turned up on the beach, Camastarich, near Arisaig? And he says, there's something interesting every day. Well, this week, it was Conti leaks. Imagine you just decide that you're going to side with Russia at a time when no sane person is going to side with Russia. You bottle it slightly, you change your update, but it's not enough. And I'm sure we've all seen the leaks coming. So what does SecureWorks do when stuff like this happens? You know, I mean, when it's not people like Sean and Keith that are actually doing the hard work, actually. Well, in this case, we grabbed all the data, we ingested it into one of our data science platforms. You should all recognize this. It's just Elastic. And we started to kind of look through the data. And we set up some Teams channels and started to chat. So what sort of things could we discover from the Conti leaks data? So here is one example of what it told us. Just one small example. There's loads of stuff on Twitter. This is a screenshot, actually, of my Teams instance from earlier today. We have a whole bunch of botnet emulation frameworks, Python scripts that pretend to be the malware that participate in real time in the botnets, and then any changes they see are webhooked and popped into Teams, and the data goes into our threat intelligence management system. So this story is about something relating to observations from our botnet emulation frameworks and how it relates to Conti leaks. And there you can see, just from this afternoon, some new maldocs coming down from Emotet. So this is a story of TrickBot. Here is a TrickBot C2 configs being delivered. And here is a TrickBot C2 config. And at the top, you can see my screen is very small here, so I can't see. But you can see the version number up there. I think it's in the 10,000s at the top. And then suddenly you can see this update for TrickBot, where the C2 servers are all set to 0.0.0.0, and you'll also notice that there's a very big number in the index at the top left. So someone had managed to inject a fake update into the C2 updates in TrickBot, and that sequence number, which is a bit like the sequence number on a DNS's own file or whatever, they'd set that to the maximum it could possibly be, so no one could create a fresher one and update it. And lots of people said, well, this might have been the military. So what are Conti leaks telling us? And interestingly, as you'll see, what are Conti leaks telling us about TrickBot? So this is probably too small to see. It says the bots have been flooded with such a config that it will simply work idle. After some time, they will download a new config via Emercoin, but they will not be able to apply this config because the saboteur uploaded the config with a maximum number and the bot checks the config number. And then we've got another complaint here. Whoever made this crap did it very well. He knew how the bot works, perhaps saw the source or reversed it. He had an encoder and a private key, plus he uploaded it all to the admin panel. And this is, you probably can't see this text, unfortunately. It's all from someone called Stern. And then here you have a final update later on that evening. Forgot to pay for the anchor domain, and as a result, when trying to renew it, it was abused, and we probably fucked up the bots. This is Conti leaks talking about losing access to TrickBot back in September 2020. So what can we deduce from that? Is that because they were working together? Who is Stern? So what else did we do with the Conti leaks data? Well, we ingested it into our threat intelligence management system. This is a bit like Maltego, except it's in fact, it's more like Palantir if you've heard of Palantir. We used to use Palantir, but we stopped using Palantir because it was rubbish, and we started using this, which is made by a company called Ripjar. And you can see from this graph that there's a node on the left. This is comms, so this is the graph of communications in the leaks, somewhat summarized. And you can see that this node on the far left is clearly communicating a lot. And, of course, it's Stern. So Stern isn't some floater on the edge of Conti. He's right at the heart of it, and he was the one complaining about losing access to TrickBot. And this is a slightly different view because you may know the Conti leaks has come out in different tranches. So this one, a screenshot I just did about 20 minutes ago. And again, at the bottom right, that's Stern. He's a core member of the group just from the mesh of communications. So we can conclude that, you can tell I've done these slides just now, that Conti and TrickBot are the same group. TrickBot was the evolution of Dyer. Some of you may know that. So it's all pretty messy. If we go back to that takedown attempt, were they wounded in September 2020? So what you can see here is a list of incident response engagements. Riot. The first one starts in August 2018. There's no initial infection vector outlined against all of the riots because every single riot was preceded by TrickBot. Every riot we ever saw in riots, the post-intrusion ransomware family, was preceded by TrickBot. In fact, better than that, every one of them was preceded by a TrickBot that used a particular module, and the net BIOS name of the computer connecting to that reverse connect module was always PC 123456. Then we see the Conti coming over, so Conti was the evolution of Riot, and we can see that the initial infection vector varies. Again, you might not be able to read it, but there's vuln exploitation, there's password spray, there's a whole lot of different things going on here. You can basically just fuzz your eyes, and that text at the bottom right is entropy. When was the takedown? That's when the TrickBot disruption was. So we moved from a very consistent playbook, and then immediately after we have 2 or 3 riots, but the average dwell time from flash to bang, from initial intrusion to encryption for riot was 30 days. And suddenly we've got entropy in the playbook. So I think TrickBot was wounded in September 2020. The big question, though, is did it help anyone? We went from having a very deterministic playbook that the actor was using, that we could identify, we could trigger on, we could detect, to a much more random playbook and many, many different initial infection vectors. So maybe that takedown attempt didn't actually help the world at large. And then, of course, I don't know, was it yesterday or the day before? Suddenly we've got TrickBot leaks, and these guys are being thoroughly doxed. Of course, this morning the account was suspended. Everyone who's an amateur OSINT person should remember that the Wayback Engine is their friend. But anyway, they've set up another account, and there's lots of leaks still coming. And the TrickBot emulator feed this week. So there's an example from, again, the text is probably too small to read. I'm used to bigger screens. That's showing hashes of new modules coming down in December for TrickBot. This is the feed for this week. And you can see, if you were to look back up, you'd see the number of live C2s was just decaying exponentially. And then finally, these 2 updates, which are from Wednesday, are giving the number of seconds since the last live C2 has been seen. TrickBot is dead since Wednesday. An old friend that's been with us for years. So we've got one organised criminal gang responsible for Riot, Conti, TrickBot, Dyer, and I haven't given you the reason why, but also possibly Emotet, which I'm sure you'll find somebody, Tom Brewster or Brian Krebs or someone will be talking about this in the next few days if they aren't already. And here we have another large OCG in Russia, the Jacobits Mob. And this guy has been indicted multiple times over 10 years. There's a little map of him and his friends in our threat intelligence management system. There's a great video made by the people who did the production at his wedding. So you can find it. It's Golf Club, not Gold Club. You can find that on the internet and watch it. And you'll notice that the groom's face never appears in any of the videos. there's this little screenshot here, and I look at that, and I wonder if I've just spent the last 5 years of my life fighting these guys with the champagne. In that video, there's a picture of the wedding party, and you'll notice a couple of very similar gentlemen sitting in the front row. If you focus on the one on the right, I think you will agree, if this screen is up to it, that this is the same chap. And this is Edward Bendersky. Bellingcat, famous for lots of reasons, identifying the fact that the Russians shot down MH17, identifying the Skripal poisoners and everything else. They put out this report on the assassination of a Georgian asylum seeker in Berlin, and in it, they're talking about the handler of the assassin was this guy, Edward Mandersky, the chap I just showed you a picture of. It says, Bendersky is also the father-in-law of Maxim Jacobits, FBI's most wanted hacker, with a $5 million bounty in his head. And later on in the report, it says, when we reached out to Edward Bendersky, he told our partner publication that he had never heard of or was familiar with Krasikov, yet they phoned him on the phone number that they had from the metadata that had called the assassin during the time. So, two very large OCGs, and actually I just stop saying OCG because everyone thinks it's cliched now because of that TV program, Organised Criminal Gang, that are responsible for the vast majority of e-crime that's going on out there. And we've been saying it for years. Is e-crime a spotty kid in a hoodie? No. It's serious people staying in office blocks in Moscow, and as Alex, who works for me, used to be in this Australian Federal Police, says, it's the same 200 guys chasing the same 200 guys as it was 10 years ago. Bellingcat are in Conti leaks, once more. Bellingcat themselves have been a target for a long time. So, Arik Toller received a fish saying there's been a sign-in on Google Apps for you. Elliot Higgins, whose Gmail account Brown Moses, got the same kind of fish come in. And they shared those with us years ago when we were tracking all of the fishes that a group we call Iron Twilight, but you guys would maybe know as Fancy Bear, were creating fishes and targeting lots of people. I've said it already, you may recognise Bellingcat. That's the guys that uncovered the Skripal poisoners. SecureWorks and Iron Twilight, well, we saw that the bad guys were using bit.ly links, short links, to encode the URLs and the fishes, and the victim email address for the fish was base64 encoded in the URL, so we could just set up a script and harvest all the bit.ly links. Bit.ly's API was open at the time, and build a database of all the people that the Russians were targeting, and we published that stuff on our blog. We harvested 19,500 bit.ly URLs, 7,000 email accounts. The 7,000 email accounts were all people that would be interest to someone who was interested in the Russian near abroad, in NATO, and basically you could look at the target list and say, who is interested in people like this? And you would immediately draw the conclusion it was the GRU in Russia. And then you'd ask yourself, who could create, if you wanted to false flag this, a credible list of targets of 7,000 people, and you'd need to be a large intelligence agency. So that's the first data point in terms of attribution for the DNC attacks, one that's often missed. The second one is that these 20,000 bit.ly URLs were created according to this time histogram, which is mostly from 9 a.m. to 6 p.m. Moscow time. That's a nice little attribution thing. And then, remember, the GRU is Russian military intelligence, and in April 2016, our bit.ly data told us that they were creating links every day in April 2016, except for the 15th of April. Now, the SecureWorks guys know what happened on the 15th of April. The 15th of April is the Russian Day of Electronic Fight Troops public holiday. Do you think if you are in Russian military intelligence and you're a hacker that you are a radio electronic fight troop? Trump might think this is a 400-pound guy sitting in his bed. I've just given you 3 data points that tell you that was Russian. We also collect a lot from incident response. Ransomware is the biggest deal that we deal with. It's bad when an organisation is totally taken out. Last year, our IR teams, of which we have 2 members over there, 74 post-intrusion ransomware incidents worked by our teams. Enterprises have been completely knocked offline. We've done 269 in the last 4 years. It's a complete mess. You're ransomware, and then there's lots of tripwires that you can pick up. I won't focus on the detail here, but this is one single incident where they'd left RDP exposed to the internet. They were not using multi-factor auth. They weren't seeing things like Bloodhound and Mimikatz. They didn't catch people executing nastiness with PowerShell. They didn't detect Cobalt Strike. And then they didn't detect abnormal activity by administrative users. Classic red team, classic post-intrusion ransomware actor. The key thing here is, if we look at our data set for last year, the mean flash to bang from initial intrusion to ransomware event is 22 days. All of you mathematicians out there will know that the mean is badly affected by outliers, so let's look at the median. 5 days. There are some big outliers there. The range is 1 to 111. But that is 5 days when people like us and others can actually stop this stuff. The detection window is small, but it is absolutely real. The hostile state actors have predictable playbooks too. This is a bit of a laugh, this one, but it's very predictable. These are screenshots from a Chinese APT group on a network that we discovered in January. It's quite a serious incident, actually. With the screen share, you're not going to see this. This is them raring up a database. And then this one here, you can see what I regard as the classic Chinese ping minus N1. I was a Unix systems administrator for most of my life. I never typed ping minus N1. That's like 4 extra characters. So you can countermeasure that. You know, what did Sean Connery say in the film? Give me a ping, just one, and then we can go and find the Chinese. Last year, we had a Chinese threat actor who was doing ping minus N3, and my entire team said I was going to have to change my presentations. Then we've got supernova. So sunburst, supernova, solar winds, all that jazz. So FireEye came out with their initial report and a Git repo, and in it they included a web shell. Microsoft came out about a week later and said, not sure why that web shell was in Mandiant's report, because it's got nothing to do with Russia, it's Chinese. So that was all very interesting. We then had found that web shell on a customer, which was quite interesting. We also had an earlier intrusion on the same client, a compromise of a vuln and manage engine and all that other good stuff. The key thing about this one, though, we blogged this, you can read it, is that the bad guys, in this case, grabbed our endpoint agent, Redcloak, and installed it in their own data center. So suddenly we had a phone home from an IP address in China, and before it managed to return its collection, they'd realized it and switched it off. So we put that in the blog post, and we thought the entirety of Twitter would go bonkers over, what was that data center in China and who was running it and all the rest of it. The only person who spotted it was Malware Tech. So it was a bit disappointing because I thought we'd get this kind of crowdsourced who is that IP address thing. Anyway, all of that is examples of things that we collect. We collect lots of things, ridiculous quantities of things, and my team's job is to make sense of it all. As I said earlier, we've invested a lot in a system that allows us to make sense of it. It has workflows that we can use to create repeated playbooks. Whenever we find something interesting, we create little investigations. We have nice wee apps that allow us to search all the things. We can quickly ingest indicators. We've got a Romanian SOC with 400 people in it. They use this, so when they see a fish, they drop it in. Once we know it's bad, we kind of crystallize this threat graph and we publish it into this other little database we call knowledge, which is then consumed by our systems. And one example which you can see of that data, it's exposed of our REST API, and we've published the Rosetta Stone of threat groups on our website, which is not static. It's coming directly from that threat intelligence management system. That same system captures all the botnet emulation system. We've got a kind of scheduler where we can put patterns in that can find new infrastructure that bad guys are doing. Each of the little blobs here, these tiny little blobs, of which there's several hundred, is an incident response engagement where we've collected all the details of what we're seeing, and then we've published that in a knowledge browser so people can sift it and work out what we know about the bad guy. So this is how we work. It's not vulns, it's not PowerShell and exploits and Meterpreter and all that. It's sort of a bit like IT in process. It might sadden you and make you think it's boring, but it's really important to have your data structured, know where it is, be able to get access to it, and to make sense of it. And this is just a wee example. For xdualsystem.com, a journalist, Raphael Satter at Reuters, rang me up and said, what do we know about it? He knew what we knew about it because we published a blog post on it. It's just a slightly artificial example. But, I can pivot off that. I can see, we've written a threat intelligence product. I can see that it's linked to some other domains and it's linked to a Chinese threat group. I can then traverse a little bit more and find out it's linked to more things, and I can read what we wrote about that threat group in our published threat intelligence. I could have done the daft thing and said, give me all the hashes, give me all the IP addresses, and I'd get a kind of pavement pizza thing going on here. I can go into the search app and search client telemetry, and I can get hits, which is unsurprising because all this research came from a client, and all labels are off this graph, but what you can see here is process launches and other things that we associate with that particular domain and that threat group on the client that was the subject of this blog. And that's what makes us efficient, because SecureWorks has got a lot of data. The research team is nearly 100 people. And if we were all just individuals doing our own thing, it wouldn't work. We wouldn't have the scale we need. And of course, my boss expects me to have an answer yesterday anytime something changes in the threat landscape. So we got kind of real-world outcomes there from the system. This is one simple example. Instant response. This is the DarkSide group, the guys that did over Colonial Pipeline, but this was a few months prior to that. They hit a manufacturing company in the US. We got the incident response team engaged. They fed back the Cobalt Strike C2 server. And what you can see here is the results of searches against our 9 petabytes of logs for our customers. And you can see the red node there says a customer has communicated to that IP address more than 100 times. So drill into that. It's a global manufacturer. It's a mega brand that you would all know. And we got to them before the bad guy was able to leverage his foothold in their network. We can also use this to enumerate other things. How do I know where all the victims are of Quackbot? That's a really interesting question, because nobody should know that apart from the bad guy. Well, we were quite lucky last year in that our bits of Python got promoted into being a C2 server for Quackbot. That happened if you'd been around for a long time. So we had to write a lot more code. We had a lot of angst because, of course, we had to throw away everything that we got because that wouldn't have been good. We certainly couldn't be facilitating crime, but we could at least enumerate where all the connections were coming from. Then at that time, there was a lot of problems with Quackbot itself, and a lot of the C2 servers dropped off. So we collected, in effect, an inventory of all of the Quackbot infections worldwide. The other thing, of course, that allows us to do is we can see the next hop back. These e-crime botnets have got multi-tier C2 infrastructure. Quackbot is only 2 hop. So we were able to see, after the Emotet takedown, the Quackbot guys moved their top-tier C2 servers into Moscow where they couldn't be touched by Western law enforcement. And you can't see it very clearly, but there is a green blob there just close to the Kremlin, and that's where the Quackbot C2 servers, the back hop ones, are today. So that's just a quick rattle through. I don't know how long I've been speaking for. That was probably a bit quick. I'm not sure. A quick rattle through some of the things that SecureWorks does and some of the ways that we work in terms of marshalling data and making sense of it. At the end of the day, we're not running around randomly researching cool things. We ask ourselves who our clients are. We ask ourselves what we're protecting them from. We ask ourselves, have we got the data that tells us the detail of what we need to know to protect our clients? We grab all that data, we stick it in big systems, we make sense of it, and we deploy countermeasures. And that's everything from me, and I don't know if you guys do questions or not, but I'm happy to hang around and answer any questions you've got. Thank you. No questions? No? Is that okay?
Yeah. How's it changed since the start of your time in intelligence to now?
How has it changed? Everyone has a thirst to know what's going on. So there's a slide I normally have that says in InfoSec, there's an awful lot of turbulence for very little flow. You wake up every day and you think, I've lost sight of all the changes that are going on in the threat landscape. But if you went to sleep for a year and woke up, you'd still be dealing with the same stuff. You and I were talking about it a moment ago. people don't know where their computers are, they don't keep them patched, they don't use multi-factor auth, and bad guys are still trying to make money. So I think that simplicity has been lost with the rise of, this sounds terrible, maybe sound really old, the rise of social media, the rise of instant, always-on communication. Everyone wants to know, where are the bad guys, what are they doing? And in actual fact, everyone should be saying, we had a client once that got hacked by the Chinese from a server in Mexico from a site that they didn't think they had anymore. It's like people don't understand that the basics are what's really important. That's probably a terrible answer, but anyway.
How big of a threat using Russia is cybersecurity-wise?
Sorry?
How big of a threat using Russia is cybersecurity-wise?
If you are in their sightlines, they're an enormous threat. If you go back 6 or 7 years ago, maybe longer, cheaper spending, satellite Tarla is just the most amazing thing ever, where the Russians would have a C2 server embedded in their malware, and that C2 server was located somewhere, generally in Africa, where they knew that the path back to it would be via satellite backhaul. And the C2 server itself had nothing running on it. It was just innocent. And the Russians used their own passive SIGINT collection of satellite communications to capture that and then re-inject the reply packet from somewhere else on the internet. Anyone who's put, why would you put that level of obfuscation into your command and control? Because you don't want to get caught. And that's the only reason you do that. Anyone who can put that amount of thought and detail into their framework, just purely to stymie attribution, has clearly got talent. The most complicated piece of PowerShell implant we ever saw was Russian 5 years ago. We've never seen anything like it since. They have amazing capability. The difference between them and the Chinese, say, is that until now, they have only really ever used it for national security objectives. So the SVR, the Dukes, they would only ever be going after central government. The GRU, Iron Twilight in our lingo, they were a bit more like a sort of drunken hooligan. But they really only were bringing their capability to bear when they had a mission. Unlike, say, the Chinese, who are just all over everything. And, of course, Iron Vikings, so the black energy stuff in Ukraine. So they have the capability, and they have I believe, a constraint on their intent. That's, so if you read the CISA's current threat assessment on Russia, they'll say, oh boy, have they got capability. But we believe their threshold for using it against Western targets is extremely high. I believe that to be the case too. I don't know what's going to happen if the sanctions start to really hurt Russia. I just don't. And that does somewhat worry me because their capability is extraordinary. They're an adversary that is as good as anyone else apart from Five Eyes. I'm not trying to scare you, I'm just saying facts.
Okay. Okay, so you're saying Russia is incredibly strong with cybersecurity, conflict-wise. If there's a conflict between Russia and China, who do you think will win?
A conflict between Russia and China?
Yeah.
Oh, I have no idea. I have no idea.
Like a big hacking, warfare between both.
We see so much more of the Chinese because their threshold for using their capability is different. They use it against people that are our customers. They're stealing intellectual property all of the time. And then occasionally you'll stumble across the Chinese using something which is just amazing. So back in 2012, at an NGO, we discovered Skeleton Key, which was an implant into AD, just a memory patch into authentication routines in AD, where irrespective of the SAM account name you gave, as long as you gave this kind of magic Skeleton Key password, you could get in. And when you publish stuff, you can kind of tell whether people have seen it before or not. And when it's governments that are coming back to you going, oh, could we have a sample of that? You kind of know it's cool. And that was the Chinese. It was stealthy, and it was used against a very interesting target for the Chinese. So you have to think about the Chinese as having a tier where their A-team is very, very good. But they've got all of these people who are just out there doing, in some cases, the equivalent of stealing phone books, just bulk data gathering from healthcare and other stuff.